Hey everybody, good to see you. Last video of the chapter. This is section 2.8, graph linear inequalities in two variables, and I'm glad that you're here. I got actually a real life example of someone who came to me and asked me to help them with some mathematical situation they had. If you didn't know, I'm a rock climber. That's what I do in my free time, and I go to a climbing gym often. And years ago, the owner of the climbing gym, he knew I was a math teacher, and he's like, he said that he bought a 500-yard spool of climbing rope to replace some old ropes. Great, very responsible. The gym needed some short 20-yard ropes and some long 35-yard ropes. And the owner asked me, he came to me, and said, how many of each should he cut? Should he have this many yards? Like he knew he had to move forward and replace his old ropes, but he didn't know how to do that. And so he knew he had some short walls 20 that would need 20-yard ropes and other ones that would need 35-yard ropes. So basically, what I did was I laid out my knowns and unknowns, and I knew that there was 500 yards total, and I knew that there was some would be short and some would be long, 30, 20, and 35, respectively. What I didn't know was I didn't know how many short and how many long, so I gave them each a variable, x and y. And then I wrote an equation, or in this case, actually an inequality. So however many 20-yard ropes you have, I'm going to multiply that by x. To say 20 times x is going to be how much rope I'm going to have from short ropes, and then 35 times y is going to be, y is how many, and then they're each 35, so 35 times y would give you uh, the total amount that I'm getting from long ropes, and then I'm going to add them together. And I need to make sure that's less than or equal to 500. The gym owner was like, well, yeah, I want to make sure I use all 500 yards, and so how many of each should I cut? And he thought there was like one answer, and he was confused because um, he wanted to know what that one answer was. So I'm going to graph the equation. I'm going to go dotted or solid, and I'm going to test point to shade. I'll tell you what all that means in a second. Anyway, so equation table graph. Let's take a look and let's visualize it. So we need a table. What I'm actually going to do is I'm going to graph the equation version. You can notice here this is a less than or equal to symbol, and I turned it just to graph the line. I'm going to turn it to an equation. And so now I know how to graph an equation. I go equation table graph. So I got the equation. I'm making a table, and because it's in this format, I'm going to just choose 0 for x, and you multiply 20 times 0 plus 35 y equals 500. Get this equation, and then you divide both sides by 35, and you get 14.3 approximately. I had to round a little bit. So apparently, if I choose 0x short, if x is equal to 0, and therefore I'm going to have 0 short ones and all long ones, I can get 14.3. So basically 14 ropes with a little bit of extra left over, not turned into a rope. I could also choose y to be 0. Let's make 0 long ropes, and then if that's true, then I can get 25 short ones, because 20x plus 35 times 0 equals 500 turns into this, and you divide both sides by 20, and you get the 25. So I graphed it. I put on a graph. We don't need any negative numbers, so this is going to be not a plus graph like we normally see, but an L graph. And I plotted my points, 0, 14.3 basically, and then 25, 0 right here. So that's actually step one. I graphed the equation. Then what I did was I had to think to myself, if we actually had a point that was on this line, would it actually be a solution? And like, yeah, you could technically put 25, 0 into here, and it actually works. So I'm going to keep this solid because the line is in it. The line is part of the boundary. Next, what I wanted to do is figure out whether or not where I should shade. And I'll tell you about that because actually, 0, like if I wanted to, I could have fewer than what I really did was I said there's 0, 0. Should I shade in this region 0, 0? And if you plug in 0 for x and 0 for y, it actually does give you a true statement. 20 times x is 0. 35 times 0 is 0, and 0 is less than or equal to 500. So I'm actually going to shade in shade in the region that contains 0, 0, which is down here. Anyway, all of these points represent possibilities that the gym owner had, and I'll show you a few of them. And you don't have to worry about knowing how to do this, so I'm just going to put it up and say, if you want to know, I'll show you later. There are all these different points that represent possibilities that the owner had. The owner could go 2 short and 13 long, or the owner could go 9 short and 9 long, or 20 short and 2 long, or even 6 short and 4 long. I put them all, and I didn't actually show the owner in real life. I didn't show the owner this graph. What I really did was I showed him this simplified table. You could have 2 short and 13 long, 9 short, 9 long, and then this is how much excess this is how much it would require. He had 500. You notice this point 2, 13 isn't actually right on the line. It's like kind of below it. That's because I'm only using 495 of the 500. So once I showed the owner these options, he started thinking, oh yeah, wait a minute, I don't have to do just one thing. I have all these different options. And you also have the option of just cutting six of these and 4 of these, and only using 260 of your 500. Like, you're not going to be using the entire spool if you go for an option that's down here. You could just save it for later and cut it later when you feel like you need it later. And the owner was actually really thankful that I was able to give him this table. It helped him, clarify his thinking, and I'm not even actually sure what he did afterwards because he felt empowered to make the decision on his own. There wasn't just one answer; there were many answers, and they were all represented here in this shaded region, and some of them were on the table that I gave him. But this illustrates exactly. First of all, if math ever comes up and surprises you, and it'll come like in the actual real world, if you're walking down the street and boom, you got to use some math, it'll come in the form of a word problem. So I'm really happy to finally get to the point where we can do some really significant word problems to illustrate what we're doing. The process is going to go like this. First, you're going to graph the equation version. You got to figure out if it's dotted or solid, and then you got to do a test point to figure out what you're shading. Let's get practice at this test point thing. Tell whether a given, my test point over here was 0, 0. You put it in and you find if it's a true or false statement. So the answer to these is going to be, is it true or is it false? And the answer is a yes or no. It's a yes or no question. Tell whether the given ordered pair is a solution of this. So we're going to do it 3 times at 3 different points, 3 different ordered pairs, and see it'll be yes or no. Here, if we plug in 0 for x and -4 for y, it looks like this. And you can, order of operations, 5 times 0 gives you nothing. -2, -2 times -4 gives you +8. And is 8 less than 6? No. So the overall answer is no. Let's do another one, 2, 2. You put it in here. 5 times 2 is 10, and then -4. 10 minus 4 is 6. Is 6 less than 6? Not really. 0, 10. Plug it in. 5 times 0 is 0. -2 times 10, which is -20. Is -20 less than 6? The answer is yes. The answer in these kinds of questions, it's not a yes, it's not a no, it's not a number, it's either a yes or a no. Alright, next. Graph y is less than or equal to -3. So again, we're going to do the 3-step process. We're going to first graph the equation version. We'll figure out if it's dotted or solid, and then we'll do a test point to shade. Alright, so graph. The equation version is just y is less than or equal the equation version is y equals -3, and I have it memorized that the equations like y equals -3 are horizontal. That's because I go along the y-axis down to -3, 1, 2, 3, and then I go across the axis to make my line. Okay, so we got to figure out, should this be dotted or solid? I think it should stay solid because of the symbol. The symbol is less than or equal to, so this symbol, less than, would be dotted, but this symbol it should be solid. If it has the or equal to line underneath, then that means it's going to be solid. All right, let's put a test point in. Let's put in 0, 0 right here. Should I shade in this point and all of its neighbors in this region? The answer is no, because I put in 0 for y. There's no place to put in 0 for x, but if there were, I would put it in 0 as well. And the question is 0 less than or equal to -3? And the answer is no. So I'm not going to shade in 0, 0. I'm instead going to shade the other region. Some of you have a rule back from Algebra 1. Maybe your teacher taught you if you see y symbol and then everything else, then the less than means shade below. And that does work. It's kind of a shortcut. It doesn't always apply because you don't always have, like in this case, it's very difficult to look at because you've got the x and the y on over here. So the shortcut doesn't work. But test points always work. All right, let's do this 3 more times. Here we go. Graph, equation, dotted or solid, test point or shade. Let's rock and roll. Oh, wait a minute. I've got for you an audio check. What's Mr. Bergman's favorite movies? That's Lord of the Rings trilogy, back from the 2003, the early 2000s, directed by Peter Jackson. Lord of the Rings trilogy. Hours and hours of lots of fun. All right, here we go. Let's graph. First step, graph the equation. How do we graph an equation? Equation table graph. So there's the equation version. Notice it used to be, the question dictates a greater than symbol, but I'm changing that to an equal sign so that I can graph a line. I think I'm just going to go 0, 1, 2 for my inputs. When we know how to do this. I'll give you a moment to write it down. And then let's graph that line. Boom, boom, boom. Now we got to ask ourselves, so we finished graphing the equation. Now, is it dotted or solid? Well, this greater than symbol means that we're going to indicate that this line is actually not a solution. It's just going to be the boundary line between the solutions. So I'm going to do it dotted to show that, for example, 0, 1 is not a solution. And 1, -1 is not a solution, but it is on the boundary that separates the solutions. All right, next, test point to shade. I'm going to choose 0, 0. Again, you can always choose 0, 0 unless it's actually on the line, and then you have to use a different test point. But I think it's easiest to do 0, 0. And there it is. And I'm going to plug 0 in for y and 0 in for x. And you can see here, 0 is greater than -2 times 0 plus 1. You do the multiplication. You do the addition, and you get 0 is greater than 1. That's not true, so don't shade in 0, 0. Instead, shade in everything else. Like this. Okay. Next, so what this means is this shaded region has all the different values, all the different pairs, ordered pairs of x, y that would satisfy this equation. So like, I don't know, 100, 100 is all the way out here. Or just 5, 5 is this point. It's shaded. If you plug in 5 here and 5 here, you'll get an inequality that is true. 5 is greater than, what is that, -9. Okay, anyway, let's do this 2 more times. Here we go. First step, graph the equation. I need to write the equation because right now it's an inequality. So the equation version of this is just y equals 3x plus 5. We're going to go equation table graph in order to graph it. 0, 1, 2. And for this last row, you're going to 3 times 2, which is 6, and 6 plus 5. I'll let you figure out what's under the red dot. All right, I've got some points to plot, and this is what it looks like. And now I have to ask myself, now that I'm finished graphing the equation, is it dotted or solid? Right now, I think though the symbol, the less than or equal to symbol, means that we should be drawing a solid line. The points here do actually represent solutions that are going to work here, like 0, 5. If you put 0 in here and 5 here, it's going to be 5 is less than or equal to 5. And that is a solution, so we want to make sure we indicate that, we show it. All right, next, let's do 0, 0. Is 0, 0 going to work? Let's put it into the original and find out. 0 times 3 is 0. You do the multiplication, you do the addition, you get 0. Is 0 less than or equal to 5? Wait. It is less than, 0 is less than or equal to 5. So ding, we should shade in the point 0, 0 and all of its neighbors. Just like this. Shade it in. Great. Okay. Let's keep on going. Last one. And so then we're going to go, first step is to graph the equation. What's the equation? It's not less than symbol, it's equal to symbol. X plus 2y is equal to 8. All right. Because this is in x's and y's over here, I'm just going to go 0, 0 table to find the intercepts. When x is equal to 0, you plug it in, you solve this equation, and you get y equals 4. Now I'm going to plug in 0 for y also, and I'm going to back calculate the x. 0 goes in for y. You get x plus 0 is equal to 8, and so just x is equal to 8. Let's plot those points. Here they are, 0, 4, and 8, 0. Now I have to figure out, is this line, we finished graphing the equation, is this dotted or solid? And I'm looking at this symbol, it's just a less than symbol, so I'm going to make this dotted to indicate that although this is the boundary, the actual points on the boundary don't satisfy the original equation, the original inequality. Alright, so next, let's pick a test point of 0, 0. It works because it's not on the line. And so we have to plug it back into the original and see, do we get a true statement? 0 plus 2 times 0, is that less than 8? Yup, 0 is less than 8. So I do want to shade 0, 0 and the region and all of its neighbors around it. Like this. Alright, y'all. Thanks for listening. Take care. And why don't you come to class and tell me what your favorite movie is? See ya.